Welcome back. Today we're moving on to lesson 7. Okay, we're going to start talking about function operations. Now, in this one, there's actually going to be nothing new, nothing earth-shattering for you. I just want to review some basic function operations before tomorrow we get to the really new piece on composition functions. Now, first of all, function operations. What I mean by that is we're talking about addition, subtraction, multiplication, and division. And for each of these, there's two ways they can note it. They can note it like this, f plus g of x, so adding the two functions, or here they can note it separately. So just notation-wise, I do want you to understand those are exactly the same things, okay? They're working exactly the same way. So, keeping that in mind, today is literally just repracticing each of these skills that you've already done. All right, so adding two functions together. Well, here I have x squared plus 2, then I'm adding it with x minus 3. So when you're adding, it literally is just basically combining like terms. I have an x squared, x, and then 2 minus 3 leaves me with a negative 1. So that's really all adding is, combining like terms. Now, what I want you to state their domain. Well, remember domain for any polynomial. So remember, this is a polynomial, just like back in chapter 5. The domain of any polynomial is always all real numbers. There's no restriction on the x values you can use here. What about when I'm subtracting? So here I have x squared plus 2 minus x minus 3. Well, again, this is essentially that idea of combining like terms. It's the same thing over here. I have an x squared. Now I'm subtracting the x, and now I have 2 minus a negative 3. Minusing a negative 3 is the same thing as adding the 3. So this time I get that as my polynomial. And again, because it is legitimately just a polynomial, the domain is going to be all real numbers again. Multiplying. So here I'm going to have x squared plus 2 with x minus 3. When I see something like that, I hope you recall the key here is foiling. Make sure you FOIL this together. I get x cubed minus 3x squared plus 2x minus 6. So that's often going to be the case when you end up having to multiply two things together. A lot of times it could end up foiling out. This is, again, just a polynomial. So my domain is going to be all real numbers. The division one, f of x, which is x squared minus 2, divided by, plus 2, divided by g of x, which is x minus 3. Well, there's nothing I can really do with that, okay? Nothing that I can simplify. But the domain finally gets interesting to talk about, okay? Because we have a polynomial on top, so we're going to start by saying all real numbers, except one thing, okay? You need to remember that we cannot divide by 0. So because we can't divide by 0, what that ends up meaning for us is we can't let ourselves use a value where x is 3. Because notice this, if x were 3, that would force me to divide by 0, something that I cannot allow myself to do. So we do have to add in that restriction in this case. X is not going to be able to be 3. All right, well, there's our first most basic cases when we're dealing with two polynomials. However, some more interesting things can happen when we use different types of functions. All right, so let's take a look at this. f of x plus g of x. So I'm taking 4x plus 7, and I'm adding that with the square root of x plus x. Again, this idea of combining like terms, well, 4x and x give me 5x. I have my 7, and then that square root of x can't combine with anything. Remember, square roots are different than powers, so you can't really combine it with the x or the 7 or anything. Each of those has to stay distinct because they're not like terms. Now, the interesting thing, though, is when it comes to our domain. Here we get to have another interesting conversation. Because I have that square root in there, there's certain things that I can't do. For example, I can't take the square root of a negative number. So because I can't take the square root of a negative number, I have to guarantee that my x's, they all have to be greater than or equal to 0. That's the only way I can do this because, again, I can't put any negatives inside that radical. What about my next one? Subtracting the 2. So 4x plus 7, this time minusing the square root of x plus x. Well, again, like terms, 4x minus x is going to give me 3x. Still have that plus 7, this time minusing off the square root of x. Remember, we can only combine like terms, and those are the only like terms that we've got. Domain is going to be a very similar situation. For our domain, remember, we cannot put negatives inside of a square root and get real solutions. So I have to limit myself to only putting in 0 and above. I can only put in positive things, no negatives inside that square root. Our last examples come from these two. F of x times g of x. So x squared minus 9 and x plus 3. So when I'm multiplying them together, again, the key here is FOIL. I get x cubed plus 3x squared minus 9x minus 27 when I FOIL those out. My domain, because it's just a regular polynomial, is going to end up being all real numbers. Okay, remember, whenever you get a polynomial, that ends up being the case. When I divide these two, x squared minus 9, x plus 3. Now this time something more interesting actually comes of this. Something very interesting happens. Note on top, the top can actually factor. That is the difference of squares. So yes, factoring does come back. Now this is something we're going to cover much more come chapter 8. But if I want to simplify this, since I have the same thing top and bottom, I can actually simplify that all the way down to x minus 3. Okay, so that's going to be something really unique. Something, again, you're going to see a whole lot more of come chapter 8. But it's a fun thing to see now that when you're dividing polynomials, sometimes, just sometimes, they end up actually simplifying. Now, what about our domain? Well, we started with a polynomial on top, so all real numbers. However, because in the original context of the problem, we had that x plus 3 that we were dividing by. Because we originally started a problem that way, it doesn't matter that it canceled off. You actually still have to exclude that from the domain. We cannot let x be negative 3 because when we started the problem, it would have made us divide by 0, something we know that we can't do. All right, so Even though that was pretty quick, I feel like there's a lot of good stuff in there. So, summary time. Now, I don't think that you're gonna have much difficulty with this, but in your summary, I want you to write the tips of the operations. So what to think about when you're doing the operations that I was kind of talking about along the way, and then the tips about the domain. Those are kind of the two things I want you to discuss in the summary, because again, I didn't actually lay it out for you in the notes, so I want you to write about that. You tell me what you think and how you're going to remember that. So again, thank you for joining me, and then make sure you come back with those tips written and ready to do your practice work.